Hi everyone, welcome to my MacPhi channel. We already know definition of prime numbers and composite numbers. But here in this video, we will discuss fundamental theorem of arithmetic. According to this theorem, any composite number can be expressed as product of primes uniquely. Uniquely term is most important here in fundamental theorem of arithmetic. Now, according to fundamental theorem of arithmetic, we can say 4, 100, 27, these are all composite numbers because 4 can be expressed as 2 into 2, that is product of 2 prime numbers, 27, 3 into 3 into 3, product of 3 prime numbers, 100 is equal to 5 to the power 2 into 2 to the power 2, that also can be expressed as 4 prime numbers and so on. Now, another example, 23 into 29 plus 23, we can take out 23 as common. Then it will be 23 into 30. That implies 30 again we can express 3 into 5 into 2. So, this number is we can express as product of primes. So, it is also a composite number. Now, based on fundamental theorem of arithmetic, we can say 1 is not a prime number. Neither prime nor composite. If it is a prime number, then we can say it would be any number which can be expressed as prime product of primes would not be unique. As for example, we are taking 4. 4 is equal to 2 to the power 2 into 1 to the power 3, 2 to the power 2 into 1 to the power 100 and so on. But this will not be unique. So 1 is not a prime number. Now, if 1 is composite, then it can be expressed as product of primes. Since 1 itself not is a prime number, so 1 is not a composite number also. So 1 is neither composite nor prime. Now, based on fundamental theorem of arithmetic, we can solve some typical basic problems. As for example, 54 is equal to 2 to the power x into 3 to the power y into 7 to the power z. It is already given. We have to find out x plus y plus z. Since 54 is a composite number and according to theorem, it can be expressed as product of primes uniquely. So you can write 54 is equal to 2 into 27 means 2 into 3 into 3 into 3. That implies 2 to the power 1 into 3 to the power 3. But there is no factor 7 in case of 54. So you can write into 7 to the power 0 since 7 is not a factor of 54. Now comparing this with 2 to the power x into 3 to the power y into 7 to the power z, we can compare left hand side and right hand side. We can say x is equal to 1, y is equal to 3 and z is equal to 0. So x plus y plus z, x plus y plus z is equal to 1 plus 3 plus 0, that is 4. Okay. Now second problem. We are talking about second problem. Same thing. 63 we can express as 3 into 21, matlab 3 into 3 into 7. That implies 3 to the power 2 into 7 to the power 1. But in question it is given 2 to the power x into 3 to the power y into 5 to the power z into 7 to the power k. Now comparing these two sides, since 3 and 7, 3 and 2, 3 is factor of 63, 5 and 2 are not factors of 63. So you can write 5 to the power 0 and 2 to the power 0. Now comparing these two sides, we can say x is equal to 2 to the power x. So x is equal to 0, 3 to the power y. So y is equal to 2, 5 to the power z. So z is equal to 0 and k to the power 7 to the power k. So k is equal to 1. Now we have to find out x plus 2y plus zk. 2y plus zk is equal to x matlab 0 plus 2y means 4 plus zk. Z is 0 and k is 1. Zk matlab 0. That implies this is equal to 4. Similarly, we can find out factor tree. We can fill in the blanks present in factor tree. As for example, 150 is a number which is composite. Here in factor tree 2 is here, so next number will be 75. So we can fill in the blank, that blank will be 75. Again 5 is another prime number. 5 into 15, 75. So this blank we can write 15. And now again 2 blanks are there. That implies one is 3, another is 5. So 150, prime factors of 150 is 2 into 5 into 3 into 5. These are the problems. Okay.